If you've been following the Next.js series, you know we've built out our routing structure, mastered server and client components, and now it's time to talk about something equally critical: where your data actually lives. In this video, we're building the foundation of the Taskmaster app, a production-ready task management system. And that foundation is PostgreSQL. We'll walk through PostgreSQL Basics, design a real-world schema for users, projects, and tasks, understand relationships and foreign keys, and get PostgreSQL running locally. Whether you choose Docker or direct install, by the end of this video, you'll have a database ready to connect to your Next.js backend. Let's dive in. PostgreSQL Basics. What is PostgreSQL? PostgreSQL is a powerful open-source relational database. It's been around since the 1980s, and it's the gold standard for production applications. Here's why developers love it. It's ACID compliant. That means your data is reliable. It supports complex queries and it scales. It's used by companies like Spotify, Instagram, and DuckDB. And it's free. For the Taskmaster app, PostgreSQL gives us the structure we need to organize users, projects, and tasks into meaningful relationships. Core concepts: schemas, tables, rows, columns. Let's talk structure. A PostgreSQL database is organized like this. A schema is a namespace, a container that groups tables. Think of it like a folder. A table is where data lives. It has rows and columns. A column defines a piece of information, like email or created at. A row is a single record, one user, one task, one project. So if you think of a spreadsheet, the table is the whole sheet. A column is a vertical list of one type of data, and a row is one horizontal entry. Same concept, just in a database. Data types in PostgreSQL. PostgreSQL supports a lot of data types. Here are the ones you'll use constantly. INT, whole numbers, 1, 42, 999. Text, long text strings, perfect for descriptions. Varchar, which stands for variable character, text with a maximum length, good for emails or usernames where you want to enforce a limit. Boolean, true or false. Binary, yes or no. UUID, a unique identifier. It's like a super secure random ID, perfect for primary keys. Timestamp, date and time, when something happened. And JSON-B, store structured data as JSON, super flexible. We'll be using UUIDs and timestamps a lot in our Taskmaster schema. Primary keys and constraints. Every table needs a primary key, a column that uniquely identifies each row. It's usually an ID. No two rows can have the same primary key. It's like the social security number of your data. You'll also want constraints to keep your data clean. Not null means a column must always have a value. You can't leave it blank. Unique means no two rows can have the same value. Perfect for emails. Every user must have a unique email. Default. If you don't provide a value, the database automatically uses this one. For timestamps, we often use the current time. These constraints might feel like extra work, but they save you from bugs and data corruption down the road. Designing the Taskmaster schema. Understanding the domain. Before we write SQL, let's understand what Taskmaster is. Users create accounts. Each user can create multiple projects. Projects contain tasks. Tasks can be assigned to team members. Team members can have different roles. So our schema needs to answer who owns what, who's working on what, and when did everything happen. We'll have 4 tables: users, projects, tasks, and assignments. Each one answers a part of that question. The users table. Let's start with users. This is straightforward. Every user gets a UUID, a unique ID. It's auto-generated. An email field. Varchar 255, not null, and unique. No two users can have the same email. Full name, just text. Password hash. Never, and I mean never, store passwords in plain text. We store the hashed version. If the database is compromised, passwords are still safe. Created at and updated at. 2 timestamps. The database automatically populates created at when the record is inserted. Updated at changes whenever the row is modified. That's it. Clean, simple, secure. The projects table. Projects are owned by users. Each project gets its own UUID, an owner ID field. This is a UUID that references the users table. It's called a foreign key. It points to a specific user. A title and description. Created and updated timestamps. Here's the key part. We add a constraint. On delete, Cascade. This means if a user is deleted, all their projects are automatically deleted too. It prevents orphan data.
projects floating around with no owner. This is called referential integrity. The database keeps your relationships clean. The tasks table. Tasks belong to projects. UUID for the task ID. Project ID, a foreign key pointing back to the projects table. Title and description, a status field. Varchar, defaults to to-do. Can be to-do, in progress, or done. This tracks the workflow. A priority field, defaults to medium. Can be low, medium, or high. Helps teams focus on what matters. And timestamps. Again, on-delete cascade on the project ID. If you delete a project, all its tasks vanish too. The assignments table. This is the most interesting table. It's a junction table. It connects users to tasks. A task can be assigned to many people. One person can work on many tasks. That's a many-to-many relationship. We handle it with this middle table. UUID for the assignment ID. Task ID, which task? Assigned to user ID. Who is it assigned to? Assigned by user ID. Who made the assignment? Useful for tracking accountability. A role field. Default is contributor. Could also be reviewer, lead, whatever your app needs. Created at timestamp. And here's something important. We add a unique constraint on task ID and assigned to user ID together. This means one person can't be assigned the same task twice. It prevents duplicate assignments. All three foreign keys have on-delete cascade. If any of those records get deleted, the assignment is cleaned up. That's your schema. 4 tables. Clean relationships. Referential integrity built in. Foreign keys and relationships. What are foreign keys? A foreign key is a column that references the primary key of another table. It creates a relationship. When you add a foreign key constraint, PostgreSQL enforces it. The database won't let you create bad data. For example, you can't assign a task to a user that doesn't exist. You can't create a project owned by a user that's never been created. The database prevents it. This is data integrity. It's worth the small upfront effort. One-to-many relationships. One user can create many projects, but each project belongs to exactly one user. That's a one-to-many relationship. In the database, we represent this with the owner ID foreign key in the projects table. It points back to the users table. Every project has an owner. Every owner can have multiple projects. Same with projects and tasks. One project contains many tasks. Many-to-many relationships. Many users can work on many tasks. One task can have multiple team members. That's a many-to-many relationship. You can't represent this with a simple foreign key. You need a junction table, a middle table that stores the connections. The assignments table is that junction table. Each row represents one assignment. One user, one task, linked together. If you need to assign 5 people to one task, you create 5 rows in the assignments table. Referential integrity and cascade rules. On-delete cascade is a rule. It says, if you delete the record being referenced, automatically delete all records that reference it. Example, you delete a project. What happens to all the tasks in that project? With on-delete cascade, they're deleted automatically. Without it, you'd have orphan tasks. Tasks with no project. That's messy. Your code would break. Users would see weird data. There are other options. On-delete set null would set the project ID to null instead of deleting the task. On-delete restrict would prevent the deletion. You can't delete this project because tasks still reference it. For Taskmaster, on-delete cascade makes sense. If a project dies, its tasks die too. Setting up PostgreSQL locally. Docker setup. If you have Docker installed, this is the fastest way to get PostgreSQL running. Open your terminal and run this one command. Docker run -name taskmasterdb -e postgres password, your password, -e postgresdb taskmaster, -p5432-5432-d postgres. Let me explain what's happening. -name taskmasterdb, we're naming the container. This is how you'll reference it later. -e postgres password, set the password. Replace your password with something strong. This is the password for the Postgres admin user. -e postgresdb, create a database called Taskmaster automatically. Saves you a step. -p5432-5432, map port 5432 from inside the container to your machine. Port 5432 is the default PostgreSQL port. D, run in detached mode. The container runs in the background. Press enter. The image downloads. In a few seconds, PostgreSQL is running. Now connect to it. Run psql-h localhost-u postgres-taskmaster. It will ask for a password. Enter the one you set above. You'll see a prompt that says taskmaster ==.
you're connected to your database. Direct install on macOS. If you prefer not to use Docker, macOS users can use Homebrew. Brew install PostgreSQL at 15. This installs PostgreSQL 15. It's the latest stable version. Start the server. Brew services start PostgreSQL at 15. Brew registers PostgreSQL to run automatically when you boot your machine. Create a database. Create a DB Taskmaster. Connect to it. PSQL Taskmaster. Done. You're in. Direct install on Windows Linux. On Windows, go to postgresql.org. Download the installer for your architecture. Accept the defaults. Set a password. PostgreSQL is installed. On Linux, use your package manager. For Ubuntu or Debian, sudo apt-get install PostgreSQL. Then, start the service and create a database the same way as macOS. Running our SQL schema. Now that PostgreSQL is running, let's create our tables. Create a file called schema.sql. Copy all 4 create table statements into it. Save it. In your terminal, run psql d taskmaster-f schema.sql. This executes all the SQL in the file against your Taskmaster database. Or, if you're already connected in PSQL, you can just paste the SQL directly. Copy it from the editor. In PSQL, paste it. Press Enter. Now verify it worked. Run this command, dt. That's \dt. It lists all tables. You should see 4. Users, projects, tasks, and assignments. Perfect. Your schema is live. You have a production-ready database locally, ready to connect to your Next.js app. Recap. You've now got a PostgreSQL database running locally with a real-world schema. You understand one-to-many and many-to-many relationships. You know what foreign keys are and why they matter. In the next video, we're connecting this to your Next.js app. We'll use an ORM called Prisma. It lets you query your database from JavaScript without writing raw SQL. You'll learn how to create records, fetch data, and build API routes that actually talk to your database.